Okay, good morning class. So today we're going to look at exponential and logarithmic functions. We're looking at exercise 5, and exercise 5 is on page 56. Feel it on our bones, we're finishing the syllabus. Okay. 12 years, you say. You're going to do nothing next year. The struggle continues. People, for each of the functions, f of x given in question 1.1 to 1.4, right? Okay, so we must do this for all of these questions. Okay. So let's go with A. 1.1. Okay, so write down the equation of the inverse of f. So what do? We interchange x and y, not so. So we say x is equal to 1 over 5 to the y. So y is equal to log x base a fifth. Or it could also be written as negative log x base 5. We spoke about that already. This is for the inverse of f. Okay, that is f to the minus 1. Okay, that is A. The B part of the question says, draw the sketch of f clearly showing 2 points on the curve of f. It would be here. So we draw the table. So the f of x graph is x and y. Sorry, minus 1, 0 and 1. So 1 gives us an answer, minus 1 gives an answer of 5, 1 and 1 over 5. So if I draw this graph, so it's 1, 2, 3, 4, 5, minus 1, 0, minus 1. So negative 1 gives you a corresponding value of 5, so that's 1 and 5. 0 and 1, and then 1 and a fifth. So the graph is a decreasing exponential function. Okay, that is your x. C says on the same set of axes, system of axes, as in 1b, draw the sketch of the graph of the inverse. So what do we do for the inverse? We interchange x and y, not so. So 1 and a fifth becomes a fifth and 1. 0 and 1 becomes 1 and 0. Negative 1 and 5 becomes 5 and negative 1. Okay, so the curve comes again close to the y-axis, doesn't touch. And it goes through like that, and that is the inverse function. And this is reflected in the line. The line y is equal to C. D. Is G a reflection of f in the x? If G is a reflection of f in the x-axis. So if something reflected in the x-axis, what do we know? Y becomes negative. Okay. So reflection reflected in x-axis, y becomes negative. Okay. So we say negative. If G is a reflection of f, so f is this equation, so it's negative y is equal to 1 over 5 to the raised to the x. So y is equal to negative, open brackets, 1 over 5 to the x. And this is the equation of G of x. Okay, that's T. Let's look at E. In E, if H is a reflection of f in the y-axis, if something reflecting the y-axis, what do we say? It becomes E. The reflection reflected in y-axis, x becomes negative. So what do we have? So we replace x with minus x. So f of, not f, but the y. What could have said f of minus x, the same thing, no? 1 over y raised to negative x. But because of the fraction, we'll flip because of the negative. So therefore y is equal to 5 to the x. And this is the equation of h of x. Okay? Any confusion here? No? This is the 1.2. Let's take this off here. Now we're going to look at 1.2. Is f of x equals 6 to the x. Now A was to draw the graph. So we'd use the table. Sorry? A was the inverse. Okay, good. What do we do for the inverse function? We interchange x and y. So x is equal to 6 to the 1. So y is equal to log x base 6. So this is the inverse function of it. Okay? We either wanted to draw one over 6, 1 and 6. Alright, so let's do that. Shukran. That one. Yeah, no problem. So that's going to be negative 1, 1, and 0. So negative 1 gives you 1 over 6, 0 gives you 1, and 1 gives you 6, of course. So the graph is an increasing exponential function. Okay? That's B. Let's look at C. C says, on the same system axis, you must draw the inverse function. So what do? We interchange x and y. Okay, this one will come over a bit. 6 will be more further up. Okay, so negative 1 and a 6 become a 6 then, negative 1. Not so? 0 and 1 becomes 1 and 0. And 1 and 6 becomes 6 and 1. Graph comes close, but does not touch the y-axis. Okay, and this is the inverse function. And this graph is reflected in the line. This is the answer to C, man. It's reflected in the line. Y is equal to? Okay. Let me see. D. If G is the reflection of F in the x-axis, so if something is reflected in x-axis, what happens? Well, it becomes negative. So we have negative y is equal to 6 to the x, which implies y is equal to negative 6 to the x.
Yes, sir. They call JD on the intercom back as one house.
She's not in this class. Oh, she's very quiet. So, I thought you duplicity. Oh, JD. Okay. So g of x is equal to them. Okay, I understand. Right. D. E. They can't just call her. What's she going to miss the maths period now?
She's going up.
Oh, very good. Enjoy the weekend. If h is reflection of f in the y-axis, people, if something is reflected in the y-axis, what do we do? Bye. So what happens? X becomes negative. So y is equal to 6 to the minus x. Or it could be written as 1 over 6 to the x. Okay, and that's the equation of h of x. Okay? Any confusion there? two more, huh? Let's take the next one. 1.4. We know what's going on now. Okay. Doing 1.3. Firstly, we have to do the inverse. What do we do for the inverse function? We interchange x and y, not so. So we say x is equal to log y base 3. So therefore, y is equal to, that is going to go on to the 3, 3 to the x. And that's the inverse function of it. Okay. B says, draw the graph of that function. But we know that this graph is also the is going to be 3 to the y equals x graph. Not so. So when we draw this graph, draw the table x and y, and on the log we put -1, 0 and 1 d. Okay. So we do the substitution, then 3 to the -1 is a third, 3 to the 0 is 1, and 3 to the 1 is 3. So we draw. That is -1 and 1. If x is -1, okay, let's just put here 1, 2, 3, 3, 1. Okay. X is -1, y is a third. X is 0, y is 1. X is 1, y is 3. So what is this? Sorry. I'm actually going the other way. I'm doing the inverse function. If x is a third, y is -1. There we go. If x is 1, y is 0. And if x is 3, y is 1. So there's your log graph, which is your function. Okay? You see? They want you on the same system of axis as 1p, draw the sketch of the inverse function. So we're going to interchange x and y. So 1 and a third becomes, a third and -1 becomes -1 and a third. 0 and 1, 1 and 0 becomes 0 and 1. 3 and 1 becomes 1 and 3. That is an increasing exponential function. This is an asymptote, the graph comes close but never touches, and we would have the line y is equal to x going through. Okay? It's really simple, no? So that is C's answer. Let's look at D. D says the reflection, if G is a reflection of f in the x-axis. So if something reflects in the x-axis, y becomes negative. Because of space here, I'm going to write that down. So remember, this is your y. So negative y is equal to log x base 3. So y is equal to negative log x base 3. And here's this is the equation of g of x. This could also be written as log x base a third. Okay? And then there's D. Let's look at E. There's reflection in the y-axis. So if something is reflected in y-axis, what's the rule? X becomes negative. Not so. So we have now y is equal to log minus x base 3. Okay. But here x has to be negative, no? If you want, you can say the x has to be less than 0. But you don't have to, okay? And this is the equation of h of x. Because I remember log of a negative is not going to exist to us. Okay? So for this to be a positive, x has to be a negative. Okay? Any confusion there? Not yet. Last one. 1.4. So in A they want you to write down the equation of the inverse function. So what do you do for the inverse function? Interchange x and y. So x is equal to log y base 2/3. So that's going on to the base, so y is equal to 2/3 to the x. That is the inverse function. Okay? B. It asks you to sketch the graph of the function. So for the log graph, put -1, 0 and 1 here. Remembering that this could also be written as 2/3 raised to the y. Okay? So if y is -1, x is 3/2. If y is 0, x is 1. If y is 1, x is 2/3. So if I draw this graph, okay, so it's 0, it's in halves, so it's 1, 2, 1, 2, 2, okay. So if x is 1.5, which is this here, y is -1, or 3/2 and -1. Okay? If x is 1, y is 0. And if x is 2/3, that is 1/5, 1/2, or 5/10. The 2/3 is 2/3. 0.67, no? So it's approximately there. We'll give you 1. So it's 2/3 and 1. Okay. So the graph is going to come through like this. It's a log graph. So it looks something like this, but because of my graph not nicely drawn to scale, that's what the graph going to look like. Okay? I don't know why I've turned the thing. Oh, because of this point. Okay, I'm just going to move this point a bit over where it should have been. Can look more realistic. This is 1. I'm not going to get a nice curve here. But anyway, you guys should get the idea by now. Okay, that is your f of x graph. Okay, then the BC part of the question says draw the inverse. Okay, so if this is 2/3 and 1 is going to become 1 and 2/3, which is lower than that. Okay, that is 1 and 2/3. And then is 0, 1 and 0 becomes 0 and 1. And then 1.5 and -1 becomes -1 and 1.5. Okay. There you're going to see a decreasing what's the name graph? Exponential graph. Again, that graph is going to look something like this. Okay. But because of the values here and the graph is not drawn to scale, that's why it looks a bit lopsided. And this is reflected in the line. Always draw that if you are drawing the graph, okay? And it's inverse. Right? Let's see. Let's look at D. D says if it's reflected in the x-axis, y becomes negative. So it's negative y is equal to log x base 2/3. So y is equal to negative log x base 2/3. Okay? Or, remember if there's a negative in front of that, could be written as y is equal to log x base. So if I put 2/3 to the -1, it becomes 3/2. So both of that is the same thing. And that's the equation of g of x. So let's look at f of x reflected in the y-axis. X becomes negative. Okay, so it's simply y is equal to log minus x base 2/3. Okay, and of course x must be negative. X must be less than 0. Okay. Any confusion there? Alright. Number 2. Equation 2.1 to 2.4 is the function of log x base a. The point on the graph is given. Use the information to determine the value of a. These are okay. Alright, so find a. So for 2.1, a, that is the function. So we'll substitute 9 and negative 2 into f of x equals log x base a. Remembering that's a x and a y. So negative 2 is equal to log x, which is 9, base a. So I'm going to convert this to exponential. So 9 is equal to a to the minus 2, which is 1 over a squared, which is a squared is equal to 1 over 9. If I introduce the square root, what must I not forget? Plus minus. But because of where a is situated, this a value can't be negative. So therefore a is equal to a third. Why? Because a must be greater than 0. Okay. So that's number 1. That's A. Let's look at B. B says give the equation of the inverse. So what do I do for the inverse function? I interchange x and y. But the function now reads f of x is equal to log 9 base log x base a third. I'm looking here. Log x base a third. Okay. So what do I do for the inverse function? We interchange x and y. So x is equal to log y base a third. So therefore y is equal to a third to the x. Okay? And that is the inverse function. Alright. C. Draw the graph of f of x and inverse on the same system of axis. Okay, so we'll start with x and y. Since we are drawing, we can draw the inverse first. Then you don't have to draw the function first. So we go with the inverse first. So it's minus 1, 0 and 1. That is for the inverse function. Okay. So I put minus 1 in here, I'm going to get 3, 1 and a third. So let's draw the inverse first. So it's 1, 2, 3. Nope. That's so pretty. Okay. So x is minus 1. Y is 3. X is 0, y is 1. X is 1, y is the third. So that is a decreasing exponential function, not so. And that is the inverse function. So what do we do for the function? We interchange x and 1. So 1 and a third becomes a third and 1. 0 and 1 becomes 1 and 0, and then negative 1 and 3 becomes 3 and negative 1. So again, decreasing log function, and that is for the inverse function. Okay, and this is always reflected in the line y is equal to x. Okay, give the equation of the function g of x if g of x is symmetrical to f of x with respect to the x-axis. So if something reflected in the x-axis, what do we say? Y becomes negative. Okay, so that's the equation. So it's negative y is equal to log x base a third, which now can be written as y is equal to negative log x base a third. But negative log x base a third could also be written as what? Sorry? Log x base 3. Okay. And that is the g of x. Okay. That is DE. State the domain of G. So this is the graph they're looking at. Okay. But this was reflected in the x-axis. So if you look at the original function, the domain of this function is x is an element of or x is greater than 0. As you can see, this graph only exists from 0 in that direction. So if it's reflected in the x-axis, the y values become negative, then this graph here becomes this graph here of G. Okay, so that's a G graph. It was reflected in the x-axis. So in other words, the domain is x must still be greater than t. E, x must still be greater than 0. Okay. I'm not going to do the other three because it's the same thing being applied all the time. Okay. That basically brings us to the end of exercise 5. Alright.